Right, in this video, we're going to be talking about binning and clustering. So how do we actually transform numeric variables into categorical variables, either because the categorical variables are going to be just about as informative, or because we want to use a method, modeling method that requires categorical inputs. So how do we actually do this? Well, there's two ways. So the first one is binning, and the second one is clustering. And they're related, but slightly separate. So we'll do binning first. So if we're going to start binning something, the method we use here is cut. And so we'll say, I'll call it bind, and we'll say cut. And let's do df $life expectancy. And you can cut into a couple different ways. You can cut either into equal size pieces. So we'll do that one first. Run this thing. And then what do we have? So we have a new variable called bind that has factor levels. And let me just look at this real quick. I'll look at the first 10, for instance. Notice what I have. It's telling me what the bins are. So this first data point fell in the bin 70.8 to 83.5. The next data point fell into the bin 58 to 70.8, and so on and so on and so on. These names are not good, even though I can see this is bin 3, the biggest bin 2, the middle bin, and bin 1, the smallest bin, or the lowest bin. Those names are terrible, right? They're really, really bad. And so how do I want to do this? I can actually reset the factor names. So I'll say levels equals C, and then I can say low, medium, high. So levels means what are the factor level names in this particular, not X bind. What are the actual factor level names in this particular data set? And notice that the top bin becomes high, the middle bin becomes medium, the bottom bin becomes low, then high, and so on and so on. So all I've done here is transform the names. But honestly, like, it can make a difference, especially presenting to non-technical audiences, if those bins or any factor variable have informative titles rather than kind of random, like happenstance titles. It can make a big difference in exposition. So this is the general idea. For clustering, we need to do something a little bit different. So we need to say model equals k-means. So k-means is a method that we're going to be talking about in a separate set of videos, but it's a particular clustering method. And for right now, all we care about is that we feed in the data frame, and then we say centers equals 3. And so this is basically saying group all of these data points into 3 groups, into 3 different centers. And we'll talk at length, more length than you probably want, about how k-means works and what we do with it. For right now, we're going to run this thing. Why does that? Gotcha. Yep, I did it slightly different. So k-means is a distance-based algorithm, which means that it cannot handle missing values of any kind. Because, like, if I'm missing my x coordinate, I don't know how far I am from any data point, because I could be anywhere along the x-axis. These missing values are not tolerable. And so instead, let's look at, I don't know, we just have to give one of these. Let's say df cart, for instance, and we'll build our model. Notice, because cart has no missing values, we don't have any problems at all. But it does have to be it must be a data set that has no missing values. So how do we actually look at this thing? Well, let's plot the data frame. And we're going to say the color of the data points is going to be model $centers. I'm sorry, model $clusters, rather. So this is cluster. So this is the actual cluster itself of the data frame. So let me move my face real quick. So here we go. The colors are not ideal. I didn't pick them. If you're colorblind, this group up here is green. This one in the middle is black, and red, and this one in the bottom here is black. So it's roughly divided here and here. It's a terrible choice for default colors, and more modern plotting packages have moved away from these schemes because, like, a significant fraction of the population thinks that this is like gray, and darker gray, and that's really frustrating. But suffice to say, we have group 1, group 2, and group 3. And that is helpful. If we actually want to use this thing, so we'll say cluster equals, we need to be a little bit careful, because if I look at model $cluster right now, okay, so it looks like this is a number, but I don't mean for this to be a number. And I could actually test this, right? I could say is.numeric model $cluster. So right now this is a numeric vector, but this isn't the number 2. This is the cluster type 2, cluster type 3, cluster type 4. So if I wanted to use this thing, I would say as.factor of model $ cluster. And now I have a new variable that I could put, for instance, put into my data frame and use that as a new predictor. If I put that in the data frame, I might like remove life expectancy and fertility. I could just completely get rid of those. It's really up to you, but you have to think carefully about, oh, it actually is a categorical variable. I need to do that conversion. Like I said, I know this is dissatisfying talking about k-means in such an abstract way, but it's just a clustering algorithm that groups like data points together in a particular way. One thing I want to point out too here is that you can specify these cut values by providing a vector. So if you wanted it to be, I don't know, 60, 70, 80, you can specify the breakpoints yourself manually. If you put the number, then it's going to evenly distribute it across the range of the data, the column. And so sometimes that's fine, sometimes it's not. If you want a little bit more control, you're welcome to exercise it. So notice that these are similar. Like in one sense, in binning, we're kind of grouping just one numerical column, but clustering extends this idea to multiple columns, multiple numeric columns, in fact, as many as we want. Here we're doing just 2, life expectancy and fertility, so that it's easy to visualize, but typically speaking, we're doing this in much higher dimensional space, maybe 3 or 4 or 5, 10 predictors, and kind of boiling them down into one categorical variable. But you'll have plenty of chance to practice that on some other data sets.